All right, so using another method here, let's look at this particular graph. Let's talk number lines. The easiest thing to do, and you'll notice that I have a big note written down here, is shade the axis exactly like a number line. Now remember what dot means. Dot means to include the number. So we're going to include -2. We're also going to include +2, but we're looking at the x's. And you remember, domain means the x values, all right? So here we go. So we're going from this -2 from here to here. And look, I've already just drawn it for you. There it is. I'm doing all of these because if you think the graph goes from -2 to +2. Sure, it makes a weird shape on its way there, but who cares? It goes from -2 to +2. So a number line then, all you'd have to do is put down one end of the number line and then put down the other part of the number line, put a dot because it includes -2 and +2, and just shade. There's your domain. You're done. That's simple. Look at range. Range, remember, means the y values. So think about it. What are you doing? You're going from here to here. You're going from 0 to 2. So, okay, draw another number line. From 0 to 2, include the dots, right? So you're going from 0 to 2. You're done. That's simple. It is so incredibly simple. I love number lines for that particular reason. So 0 to 2, include the dots, you're done. There's your range. Now, let's look at a list. List makes this a little bit more complicated now. But I'm going to take away this, but I'm going to leave the number line on our graph. Okay, all the stuff that we worked on the number line there on the graph, let's do it. So let's talk about a list. Let's talk about our domain for a second. Now think about this. What is the domain? Well, the domain is going from -2, but if we drew a list, we'd have to include every single number, all the way through here like this, all the way up to here like this, and done. Well, it's impossible because there's infinite number of numbers in between them, talking decimals, talking square roots, talking everything. So it's kind of impossible to do. So in a list, what I'm going to do is I'm going to say, okay, we're going from -2 all the way to +2. Right? We're going from -2 to +2. So that x has to lie between those two numbers. So it's got to be greater than -2 or equal to. That's why we put a dot here, because a dot means equal to. And it's all the numbers have to be less than and equal to 2. So put a dot here, right? Means to include that. And the most important part to include here is that x is an element of the real numbers. There's your list for your domains. Now, this looks an awful lot like another type of notation. And if you remember, that looks an awful lot like the notation right here. Set notation. Yes, it's very, very, very similar. But set notation includes a little bit more of a formal language where you would say x such that, and then you would make this exact same statement. So really, there's not too much of a difference between using a list and using this wonderful domain statement and that type of notation. Okay, enough. Let's go to range. Range then. Range, here we go. So think about it. We're going from 0 to 2. Okay, so we're going from 0 to 2, and all the y's have to be between those two numbers, but they also have to be including the two numbers, and the y has to be an element of the real number system, okay? That's simple. Again, it's very, very similar to the formal language we're going to be using a little bit later on, but we'll get to that when we get there.